Most prospectors learn early that there's a substance called fool's gold that kind of looks like gold, but isn't. And it isn't valuable, or at least normally isn't particularly valuable, certainly not like gold itself. And so people kind of get a bad view of fool's gold. The mineral name for this stuff is pyrite. And we're going to talk a little bit more about pyrite today. Now, is pyrite always bad news for the prospector? No, not really. The truth is that it can be an excellent indicator mineral for gold, and in many cases, the pyrite itself can have little tiny particles, like microscopic kind of particles of gold inside of it. I'm Chris Ralph, the professional prospector, and today we're talking everything about pyrite. Now, pyrite is a chemical combination of iron and sulfur. They come together, and it's about 46% iron and 54% sulfur. In the real world, all sorts of things can be present in pyrite in small amounts, and this includes copper, nickel, cobalt, thallium, arsenic, and of course, gold and silver. Pyrite is the most common of all the sulfide minerals, and it occurs in quartz veins and in a lot of different kinds of common rocks. The iron that's part of pyrite is about 4.5% of the Earth's crust. It's the fourth most common mineral in the Earth's crust. Sulfur isn't quite as common as iron, but still sulfur is the 12th most common element in the Earth's crust. And you put the two of those guys together and you get pyrite. Sulfur just seems to end up in all sorts of mineralized solutions, and because it's common and iron is a common element, we end up with pyrite being the most common metal sulfur mineral they call sulfides. It's the most common sulfide mineral is pyrite. Now, pyrite is a brassy shade of yellow in color, but the shade can vary a little bit based on trace minerals and how it formed and other things. And there are often distinct undertones, and in fact, it's very common for pyrite to have a little bit of a greenish undertone in addition to the normal brassy yellow. Pyrite is found in a number of different geologic environments, in all kinds of rocks from sedimentary to metamorphic to even igneous rocks. Its most common shape is that of a cube, but it can also come in a whole lot of different other shapes and varieties. And the variations of the octahedron shape, which is the diamond shape, or even a dodecahedron are fairly common. Let's take a look at some pictures.
Here's a picture of the classic cube of pyrite. You can see the square shape. You can even see a little bit of the greenish kind of hue to it. But this is the classic square cube shape that pyrite is best known for. This is also pyrite. Now, this shape is much less common than the square cube, but this is also pyrite in the same mineral, the same formation. And this also is a specimen of pyrite, and you can see it is also a different shape. It's kind of a combination of the cube and the octahedron, and yet this is also pyrite, just like the other two.
Interpenetrating twins, where it looks like one crystal is kind of growing outside of another, are fairly common. And the faces of the cubic crystals are often striated, with the lines of the striation being on one face at right angles to those of the adjacent crystal face. Because pyrite grows into large crystals and is bright and brassy colored, when the crystals are fresh, it makes an attractive mineral specimen. And it's very much appreciated by collectors. It can be, in good formation, crystal formation, bright and colorful, a valuable mineral specimen. Some very high quality pyrite crystals are mined to be mineral specimens and are prized by collectors and valued. Let's take a look at some nice specimens of pyrite.
This is a mass of pretty sparkly cubic crystal faces of pyrite. It's about 6 inches across, and as I remember, it was for sale for about $200. But it's a nice cabinet piece. This specimen of pyrite I snapped a picture of at the Tucson Gem and Mineral Show a few years back. The big crystal, I think, was about 3 inches on the side, and these were really very pricey. This is an example of pyrite crystals that were mined just as specimens. Pyrite does come in really big crystals. I'm not sure whether this is real or photoshopped. If it is real, this thing would weigh 100 pounds or a little more. So it's fantastic if it's real. If it's not, it just does show that pyrite can be pretty stuff.
Pyrite has a hardness of about 6 on the Mohs scale and a density of about 5 grams per cubic centimeter. When struck on steel, pyrite makes a spark, which is how pyrite got its name. Pyrite, pyromaniac, it has to do with fire. Pyrite can be a good conductor of electricity, and it depends on the trace minerals that are in it, how good a conductor it actually is. It may respond even on a metal detector. Let me show you a picture.
This is a test of the conductivity of some pyrite on a piece of quartz using a voltmeter. And you can see the pyrite does conduct a little bit of electricity. It's not a good conductor, but it's conductive enough that in some circumstances, some pyrite on very sensitive metal detectors may show up.
The mineral that looks most like pyrite is a mineral called Calcopyrite. And Calcopyrite is basically a copper iron sulfide. Instead of pyrite, was just iron sulfide. It has copper in it. It looks very similar, but generally speaking, Calcopyrite, the brassy color is much darker than that of pyrite. And the fact that Calcopyrite cannot be scratched by steel, it's distinguished from gold. Pyrite is distinguished from gold by its brittleness. A piece of gold hit with a hammer will just flatten out, whereas a piece of pyrite hit with a hammer will shatter into bits. Normally, pyrite will only fool a prospector when it's fresh and unweathered, because it quickly gets a rust on it. Just like iron turns into rust on exposure to water and air. Well, pyrite also, because it has iron in it, on exposure to water and air will turn into rust. And when it has that rust color, it doesn't fool anybody to being gold. Let's take a look at some pictures comparing pyrite and Calcopyrite.
The golden mineral here is Calcopyrite, and it just has a deeper brass kind of color as compared to pyrite, which we'll look at next. Here are a couple of really nice specimens of pyrite, beautiful pieces, but you can see the color is just not as deep and brassy as the Calcopyrite we just looked at.
Pyrite has long been used as a source of sulfur for making sulfur dioxide. It's produced by basically burning the pyrite in air in furnaces and collecting the sulfur dioxide gas that's emitted. The sulfur dioxide gas that comes off the burning pyrite is widely used in industry for applications like bleaching wood paper to make the paper white, and also in making sulfuric acid. Pyrite occurs in many types of metal-bearing veins as grains or crystals embedded in the quartz or other rocks. It occurs at times as an accessory mineral in some just regular igneous rocks. In sedimentary rocks, like slate, it's sometimes found as a concretion or a rounded nodule. Sometimes even it takes the place of a fossil. And there are actually fossils that are basically replaced by pyrite. Let me show you a picture of a pyrite fossil.
This is an ammonite, an ancient sea creature, where the shell and body have been replaced by pyrite. And actually, pyrite replacing, animals for fossils is really not that unusual.
In most rocks, pyrite appears as crystals, but in veins, it can be either crystals or sometimes as massive areas of pyrite radiating out from a certain area in the vein and filling the entire fissure space that's open for it in the vein. Pyrite is often the product of igneous or metamorphic forces, but it also gets moved around in the ground and deposited by water solutions. Let me show you some pictures of pyrite in different types of ore.
Here's a piece of white vein quartz with a chunk of pyrite in it. The clot of pyrite is pretty good sized, and there's a lot of little bits of cubic pyrite in this that you can see if you were up close. But it's starting to rust. You can see around the edges of the pyrite. You can see the rust-colored material as it's starting to oxidize. As I mentioned, pyrite can be a good indicator for gold, and here you see both gold and pyrite. The darker pyrite has begun to oxidize and rust, but the gold, of course, does not rust and maintains its beautiful bright color. And here's another piece of quartz with gold intimately associated with pyrite. The darker cubes on this specimen are pyrite, whereas the beautiful bright gold is the gold. Pyrite is not always in pure form. It can be closely associated with other sulfides, including things like sphalerite or galena. This is a piece of gold and silver ore with pyrite and other sulfides. The darker clots of sulfides include things like silver sulfides together with the pyrite, and then, of course, the white quartz.
Because pyrite is such a common mineral, it's associated with a number of different kinds of deposits, including some non-metallic gem deposits. It's actually pretty common in a lot of the Colombian emerald deposits. Let me show you some pictures of emeralds and pyrite together. They make great specimens.
Here is an emerald specimen from Colombia, showing the beautiful green of the emerald and a sprinkling of pyrite throughout the specimen. Here is an even nicer specimen from Colombia, showing the beautiful green of emerald and the bright brassy colors of the pyrite.
Pyrite is chemically unstable, and it reacts with air and water, the oxygen in the air, readily to form limonite and other iron oxide minerals, basically rust. Rocks that contain pyrite are unsuitable for construction uses because the pyrite readily oxidizes. It serves to both disintegrate the rocks because the pyrite oxidizes, and then also to stain it with iron oxides. In ore bodies near the surface, where pyrite is exposed to both air and water, it's readily oxidized. This reaction is accelerated by the action of certain kinds of bacteria that like to eat the sulfur in pyrite. These reactions also occur more readily when the pyrite is ground into small sizes and dust, and this exposes more surface area for the air and water to react with. Let me show you some pictures of oxidized pyrite in ores.
Here's a specimen where all the pyrite has been oxidized to limonite, to iron oxides, but you can still see the gold peeking out through from underneath. The dark colored spot to the left of the quartz is a fully oxidized pyrite crystal that's now limonite, but you can still see the gold in this specimen because it shines and doesn't rust. Here's another piece of high-grade ore with the pyrite all oxidized into a rust-colored limonite and other stains. Now, this doesn't have any visible gold in it, but it's actually a pretty high-grade piece of ore. Here's another piece of high-grade gold ore that's fully oxidized. You can see the pyrite in the ore rock, and also a couple of free cubes that are also fully oxidized next to the specimen.
When pyrite reacts with water and air, a portion of the mineral changes into ferrous sulfate. This water-soluble chemical percolates downward into a vein or other mineral structure and aids in the formation of secondary enrichment. This basically, it helps carry down values. This is very common in copper, silver, and to a lesser extent gold deposits, that the surface minerals are carried down and concentrated at or near the water table. This process can form some really rich bonanza type deposits of these metals. Let me show you some pictures and a diagram of surface enrichment in ores.
So this is what a lot of both base metal and silver type veins, and like I say, to a lesser extent gold, look like. You have a surface leached low-grade zone, and then below that, as you approach the water table, you get an enriched oxidized zone. And so like if it was a copper deposit, this would be where you'd find azurite and malachite and chrysocolla, and then an enriched sulfide zone where you find Calcopyrite and other copper sulfide minerals that form down there. And then the low grade, the pink on this is the unaltered material that's the same as the original outcrop, but without any enrichment. And this process is all caused by the fact that a lot of these veins have a lot of pyrite in them. And as the pyrite oxidizes, it releases acids and other acidic salts and things, ferrous sulfate and sulfuric acid, that carry the values down in the vein zone and enrich them below the surface.
The part that doesn't turn into ferrous sulfate remains on the surface in the form of limonite, garrotite, and other oxides, basically rust. Normally the limonite keeps the form of the original pyrite crystals, leaving what is known by geologists as a pseudomorphic crystal. So what you end up with is basically a solid piece of rust that has the shape and form of the original pyrite crystal. You can even see the striations that are common on the pyrite crystals will remain after it's changed over to iron oxides. These cubic brown crystals are found both by prospectors when they're panning and metal detector operators. Veins and other deposits which are rich in pyrite are usually capped by a certain amount of this limonite, and sometimes it forms kind of a vuggy shape, it's not as solid as the solid pyrite crystals. It'll form kind of a vuggy type, porous type of material. And this porous type of material is known by geologists as a gossan. These gossan deposits are characteristic of weathered surface exposures of pyrite-rich metal deposits. And they can be rich in gold or silver, copper, and other types. Let me show you some pictures of oxidized gossan ores.
Believe it or not, this is a gold ore. Now, this was once a massive pyrite material. It consisted of mostly pyrite with some copper minerals, Calcopyrite and that sort of thing. And as it was being oxidized, it leached so much and so much material was removed that you end up with this porous material, which is, as I say, gossan. But it has the gold that was originally in the pyrite. A lot of pyrite does have microscopic bits of gold in it. And even though it leached and it became acidic, the gold sat there in the pyrite just the same as it was, even as the pyrite was being converted to iron oxides.
Another product that's formed by the oxidation of pyrite with air and water is actually sulfuric acid. This reaction is responsible for most of the acidic runoff from old mine dumps, including metallic mines and coal mines, because pyrite is often associated with coal too. For mine dumps that have large amounts of pyrite, this can be a real problem, and acidic mine drainage can do some real environmental damage, killing fish and plants downstream. Because both air and water are required for the reaction of pyrite, acid runoff from mine dumps is a big problem in wet areas. It's not as much of a problem in desert type areas. Let me show you some pictures of acidic mine drainage.
You can see where there's plenty of water, and the pyrite, as it's being oxidized and turned into acidic materials, if there's so much water that it drains into the local streams, you get quite a mess on your hand. This is the iron from pyrite depositing in a creek. That's why it's rusty colored, and the water will test as being fairly acidic. This causes significant environmental damage, as I noted.
Now, pyrite can be both a valuable mineral in a deposit and also a waste gangue material in a deposit, depending on the values that it holds. Where pyrite has significant gold, it's saved and it's processed for the gold that's inside the pyrite. Where it's barren, it's treated as a waste. Pyrite is found frequently associated with other sulfides like Calcopyrite and sphalerite, galena, and others in veins with significant gold because much pyrite is gold-bearing in gold veins. It's common in the gold mines of California and Nevada and other western states that part of the gold is free milling, meaning that it can be easily extracted just by crushing the ore and then taking the gold out of it. But part of the gold is also in the pyrite. The gold that's contained in the pyrite is not easily separated out, but the normal process to recover the gold is by fine grinding and leaching the ore using things like cyanide. The gold within the pyrite occurs as tiny, tiny inclusions of metallic gold. Where the forces of weathering convert the pyrite into limonite, the gold is then released from the pyrite and becomes free milling. Let me show you the association of gold and pyrite. I'm going to show you a picture of gold and pyrite in a pan.
Now, this is the result of some crushed ore in Africa. They swirled it around and showed me their concentrates. And you can see at the very head of the tail of material, there's some bright yellow gold, but then there's a lot of darker other colored material with some gold scattered through it. The darker material is actually pyrite. And the pyrite, even if you could remove 100% of the free visible gold particles, would still have some microscopic gold inside it. And the guys knew this, and they saved the sulfide concentrates and eventually sold it to someone who could treat it and extract the gold.
There are a number of minerals similar to pyrite, or at least close to it. This includes marcasite, which basically has the same chemical formula as pyrite, 1 atom of iron and 2 atoms of sulfur, but marcasite crystallizes into a different type of shape. Pyrite is also another iron sulfide mineral. The mineral pyrite is also a combination of iron and sulfur, but has a ratio of 1:1, 1 atom of iron to 1 atom of sulfur. Minerals like Calcopyrite and arsenopyrite have different additional elements in their structure. Calcopyrite, of course, has copper with the iron and sulfur, and it's an important ore of copper. While arsenopyrite contains arsenic with the iron and sulfur, pentlandite is another mineral that contains nickel with the iron and sulfur. Originally, centuries ago, when miners did not really know to differentiate much between minerals, basically all sulfide minerals were called pyrites. There are a number of different types of ore deposits I've mentioned that have pyrite or are associated with pyrite. Basically, these include things like greenstone-hosted gold deposits, mother lode type gold deposits, both low and high sulfide epithermal type, porphyries, volcanogenic massive sulfides, and others. The presence of pyrite, however, gives no assurance of value. Pyrite is a lot more common than the valuable metals that you want them to be associated with. The presence of pyrite by no means gives any assurance that it's going to contain valuable trace minerals. Most prospectors learn early that a vein may glitter beautifully with showy pyrite, liberally sprinkled through the ore, and yet still be quite barren of gold. While some pyrite veins may contain some gold, not all of it does. In fact, a lot of pyrite only contains tiny traces, amounts not worth going after. Where there is gold in pyrite, it is, like I say, usually in the form of tiny particles of metallic gold within the pyrite crystal. The ratio of free gold to gold encased in pyrite varies a lot. And some veins which do have gold have a lot of gold in the pyrite and very little gold that's free, while other types have a lot of gold that's free and very little in the pyrite. It just depends on the formation of that particular quartz vein. Finally, I want to talk about pyrite and gold chemistry. Now, it's kind of complex, and I don't want to dive in and create a giant chemistry lesson, but the way that gold works with sulfur and iron is the reason why that there are so many different gold deposits and different types of gold deposits. You know, platinum is about as rare in the Earth's crust as gold, but there are zillions of gold deposits and relatively few platinum deposits, and there's good reason why. It's the chemistry of how iron and sulfur and gold react. You see, in hot solutions, hot sulfury water, which a lot of times hot springs and that kind of stuff have sulfury water, it tends to be acidic. Acidic sulfury water will actually, at real high temperatures, way above boiling, and under pressure, will dissolve gold out of rocks. And then you've got this gold in a solution, and what happens is that when the gold encounters iron in some other kinds of rocks, the gold will literally come out because the sulfur ends up wanting to be with the iron more than it wants to be with the gold. And so the gold gets dumped like, an old boyfriend being dumped, and the sulfur goes with the iron to make pyrite. And you end up with free gold, and that's why free gold and gold in pyrite, little tiny particles of gold in pyrite crystals, is pretty common. It's because of this interaction that the gold and sulfur is not really all that stable, and when when the sulfur gets a chance to go with iron, it dumps the gold and leaves metallic gold behind. That's how this whole system works. That's the really simple version of gold chemistry. Now, y'all just debate about this kind of stuff, and there's more than one view, and so if you happen to know about the chemistry, you'll know that there's various different views on this, and not all gold deposits are the same. But it works that way, and that's why we have so many different kinds of gold deposits. Now, for those of you who want to learn more about gold deposits, and the skill of going out into the field and finding gold for yourself, I wrote a book about that. In the book, I give you the things that you need to know for the skill of finding gold. And I'm going to tell you a little bit more about my book right now. So let me tell you a little bit more about my book. It's called Fistful of Gold. And I wrote it because I want you to be able to go out and find for yourself fistful of gold. And you can see that it's an encyclopedia with all kinds of information, pictures, and that sort of thing. It's not in color, but color would have cost me a lot more to have printed, and so the book would have cost a lot more. It's for sale on Amazon, and you can pick it up. I'll put a link in the description below. I also serve as the editor for a prospecting magazine. It's ICMJ's Prospecting and Mining Journal. And honestly, you should check that out. We got stories and information, legal stuff, everything you know to increase your skills as a prospector. I write articles in this every month, and a lot of other very experienced prospectors contribute to the magazine as well. So check the magazine out. Also, I have a website, and the website is at NevadaOutbackGems.com. I'll put a link for it in the description below, but there's gobs of information there that you will find useful in your prospecting efforts. Finally, I want to say that I really appreciate your comments and thoughts, and even positive criticism. Don't come on there and just toss out insults, because I'll just delete your comments. But if you've got helpful things to say and questions to ask, do write and put those in the comments, because I answer my comments to people, and you'll hear from me in responding to you. So if you've enjoyed this video and you like what you see and you're interested in finding out more, well then sign up, subscribe, and hit the notification bell so they'll let you know when I post new videos. And like it and share it if again you see stuff that you really are excited about. And I'll be coming out with lots more new videos, and so we'll see you again real soon.